Good afternoon, sir. My name is K. Manideep. My tech talk topic is current source converters. A current source converter is characterized by the fact that the DC current flow always in one direction and the power flow reverses with the reversal of DC voltage as shown in figure B. Whereas the voltage source converter in which the DC voltage always has one and the power reversal of DC current as shown in figure A. In shown in figure A, the converter box for the voltage source converter is a symbolically as shown in figure with a turn-off device with a reverse diode. Whereas the converter box as shown in figure B for the current source converter is shown without a specific type of device. This is because the voltage source converter requires turn-off devices with reverse diodes, whereas the current source converter may be based on diode, conventional thyristor, or the turn-off devices. Thus, there are three principal types of current source converters as shown in figure C, D, and E. The figure shows voltage source converter, current source converter, diode rectifier, thyristor line commutated converters, self commutated converters. These are current source inverters. Voltage source converter input is DC power and output is active power and reactive power. Diode rectifier or diode converter. It represents the diode converter which simply converts AC voltage to DC voltage and utilizes AC systems voltage for commutating of DC current from one value to another. Obviously, the diode based line commutating converter just converts AC to DC power without any control, and also in doing so consumes some reactive power on the AC side. Thyristor line commutated converter. It is based on conventional thyristor with gate turn on but without gate turn off capability as shown in figure D. It utilizes AC systems voltage for commutation of current from one valve to another. This converter can convert and controls active power in either directions, but in doing so consumes reactive power on the AC side. It cannot supply reactive power for the AC systems. Next one, self-commutated converter. It is based on turn-off devices, gate turn-off, GTO, MTO, IGBT, in which communication of current from valve to valve takes place. The device turn off action and provision of AC capacitors to facilitate transfer of current from valve to valve as shown in figure E. Whereas in a voltage source to facilitate transfer of current from valve to valve. The converter, the combination of current is supported by a stiff DC bus with DC capacitors provide a stiff AC bus for supplying the first fact changing current pulses needed for the computations. It also supplies to or consumes the reactive power. Comparison between difference current source converters and voltage source converters differences. Current source converters in which direct current always has one polarity and the power reversal takes place through reversal of DC voltage. Whereas the voltage source converters, the DC voltage always has one polarity. The power reversal takes place through reversal of DC current polarity. This is the important points of self-commutator converter. Conventional thyristor-based converters, being without turn-off capability, can only be current source converters, whereas turn-off devices based converters can be either type, that is current source or voltage source converter. Diode based current source converters are the lowest cost inverters. If control of active power by the converter is not is required, whereas the same type of voltage source converters are expensive. If the leading the active power is not required, then the conventional thyristor based current source converter provides a low cost converter with active power control. For current source converters, the rate of rise of fault current during external internal faults is limited by the DC reactor. For the voltage source converters, the 6-pulse current source converter does not generate that harmonic voltage, whereas voltage source converter generates. In a current stiff converter, the valves are not subjected to high due to the presence of AC capacitor, whereas voltage source converter it can be available. AC capacitors required for the current strip converters can be quite large and sensitive, whereas a voltage source converter uses small size of capacitors which are cheap. Continuous losses in the DC reactor of a current source converter are much higher than the losses in the DC capacitor, whereas in voltage converter there are relaxable.